a trick that you can use to determine the number of oxygen and the number of negative charge in some of the most common polyatomic ions. Using the sentence, Nick the camel ate clam supper in Phoenix with Brad. In this case, we look at the three patterns. The first one is the underlying letters represents the symbol of the first element in the polyatomic ions. Okay, here we have the underlying letter. The number of consonants represent the number of oxygen atoms in the polyatomic ions. So we have a consonant versus the number of vowels represent the number of negative charges of the polyatomic ions. For example, let's look at nicked. But before we look at the example, the purpose of this trick is to know the number of oxygen and the number of negative charge. Therefore, you need to know that the word nick is related to a specific polyatomic ions. For instance, nicked represent nitrate. So N is underlying, so the element symbol is going to be N. In this case, the word nick has three consonants, 1, 2, 3. Give you 3 oxygen atoms. It has 1 vowel right here, so therefore it's going to be 1 negative. And this gives you the chemical formula for the polyatomic ions for nitrate. Then we have the word camel. Camel is related to the polyatomic ions carbonate. In this case, C is underlined, so it's going to be carbon. So we have 1, 2, 3 consonants, so going to be 3 oxygen atoms. And we have 2 vowel, 1, 2, so therefore it's going to be 2 minus. Then we have chlorate, which is referred to clams and chlorate. In this case, Cl is going to be chlorine. There are 3 consonants, therefore 3 oxygen and 1 vowel, so it's 1 minus. If you haven't noticed so far that all of the polyatomic has 8 ending because of the word 8 there. So 8 for 8 polyatomic ions. In this case, the next one we have sulfur is for sulfate. The S underlying is going to be sulfur. And we have 1, 2, 3, 4 oxygen because there are 4 consonants. And then we have 2 vowel, give you 2 negative charge. For Phoenix, it's going to be for phosphate. The P is going to be for phosphorus. There are 1, 2, 3, 4 consonants, so it's going to be 4 oxygen atoms. And we have 3 vowels, so it's going to be 3 minus. Brad is for bromate. In this case, Br is going to be bromine. And there are 3 consonants, so it's going to be 3. And we have 1 vowel, so it's going to be 1 minus. Now, if you know the polyatomic ions formula for the 8 ending, you also know the formula for the 8 ending. If you look at the 8 ending, it has 1 less oxygen atom than the 8 ending. So nitrite is coming from nitrate. Since nitrate has 3, nitrite would have 2 because 1 less, so we have NO2 1 minus. Chlorite is coming from chlorate. Instead we have 3, chlorite will have 2 oxygen atoms. And you notice the charge does not change. The charge for IT ending and ATE ending is the same. And here we have sulfite is coming from sulfate. Instead of 4, now we have 3. So SO for phosphate, it's gonna be 3 oxygen atom because phosphate has 4. So we have PO3 3 minus. Another type of polyatomic ions that relate to Nick the camels is that we have hydrogen polyatomic ions. Now, by adding a hydrogen, you're adding a positive charge because hydrogen ions is 1 plus. So in this case, we have hydrogen carbonate, so it's going to be HCO3. Notice the number does not change, right, for the atoms of oxygen, but the charge is going to change. Instead of having 2 minus, now you're going to have 1 minus because the hydrogen adding a +1 to it. Then here we have hydrogen sulfate, which gives you H, and SO4 is the same thing as sulfate up there, but instead of having 2 minus, you are going to have 1 minus. Then here we have phosphate, hydrogen phosphate, give you HPO4. It's no longer 3 minus, it's gonna be 2 minus. Remember, hydrogen ions plus 1 positive charge, so it's gonna be 2 minus.